And then there's mod. And then there's mod.
Welcome back to another episode of Vision Basic. Before I get into the topic of this video, I just want to state that there is a bug remaining, I believe, in all versions of Vision Basic relating to program banks. So make sure to stick around till the end of this video. I'll explain what this bug is and how to work around it. This bug will be fixed by version 1.2 of Vision Basic, which I hope to have finished in the next couple of months. Oh, and there is an undocumented banks feature that I'll demonstrate at the end of this video as well. This feature never made the manual, and I totally forgot that this was something you can do in Vision Basic. And it should work in all versions of the software. Speaking of versions, version 1.2 of Vision Basic will be considered a beta release and won't provide as many changes that version 1.1 brought. I will give you a super tiny detail about one of those changes at the end of this video. I previously showed off how the function keys will gain, functionality, but I want to keep enough details secret so that version 1.2's introduction video will still provide a few surprises. I wish I could put out videos more frequently, but I'm working like a crazy person to get version 1.2 of Vision Basic done as quickly as I can. In my efforts to improve Vision Basic, I've been totally breaking the software in the process, so finding and fixing bugs has taken the bulk of my time. Anyhow, I started out on one trajectory for this video, and then it was going to be a video about two different topics, and now I'm just going to talk about the second topic and save the original topic for next time. The topic for this video is a bit simple, and this should allow me to get it out to you faster, so that's why I chose to go with the topic I'm about to introduce. Some versions of BASIC have what's called a mod function, which returns the remainder of a division problem. Regular C64 BASIC doesn't have such a function, so adding such a function to Vision Basic was never on my radar. I'm not even sure I've ever needed such a function, really. But I've been asked a couple times if I could add this function to Vision Basic. I'm not sure if it's something I want to add down the road, and I'll certainly consider it, though I really don't want to add any more bulk to Vision Basic's command support library. So, just as you can create user-defined commands in Vision Basic, which can also be called pseudo-commands, I guess, you can also create your own user-defined functions. User-defined functions can't be used as part of a math expression at this time, and the main reason for this is due to potential conflicts in zero-page memory. I have ideas for how to get around the conflicts, but this isn't something I'm concerned about with the upcoming version 1.2 that I'm working on. So in all versions of Vision Basic up to this point, there is a standard approach to using them, a specific formatting if you will, and we'll get to that in a moment. A typical mod function might look like this: x equals mod 111129. What the mod function does here is that it takes the value 1111, or 1111, and divides it by 29, and the remainder of the division problem will be fed into the x variable preceding the equal sign. In this case, when all is said and done, x will end up equaling a value of 9. Let me show you how to create this function in Vision Basic. First, we need to type the following: x. We're going to clear all the variables, which we should always do, and set the x variable as a decimal variable. The results returned to x will actually be integer, but who knows, we might want to do other calculations with the x variable. If speed is important, you can simply leave x as an integer. And now comes the formatting for our user-defined function. 20 mod x equals 111129. Here, mod is our function, which we haven't created yet, and we place a period after it just like we do with user-defined commands. The only difference between user-defined functions and user-defined commands is that a user-defined function will return a value back to the variable that's just after the period and before the equal sign. The two parameters that follow are the same ones you'll see in the regular mod function I typed above. You can use variables instead of values if you wish. The formatting here isn't too terribly different. The values 1111 and 29 will be passed to our mod subroutine. So as you can see here, the formatting here isn't too terribly different. It's a little confusing, but you have your parameters in both cases. This being the original mod, you know how regular basics would do it. And the major difference here is your X and mod are going to be switched, and the equal sign will be here. Okay, now let's print the results to the screen. 30, print, and we're going to just print it out the way that regular basic would format the mod command. And we'll type end so that our function routine does not end up being executed. We still don't have the actual routine that is going to calculate the results, so let's see what such a routine might look like. And we shall type description, describe, whatever, desc mod function. And for now, skip 1000. There is a basic formula for calculating a remainder. It is C equals A minus int A divided by B times B. We take B here and we divide it into A, then strip away the fraction with the integer function, and then we multiply it back with B and then subtract from A. We're essentially dividing by B, then multiplying by B, and in the middle of the process eliminating the fraction part. We're creating a value here where B is a kind of factor, if you remember that term from back in math class. The resulting value will be divisible by B and typically less than the original value. So we subtract it from the original value here to get the remainder. Since Vision Basic calculations are done strictly left to right, we'll have to change some things, but we're also going to toss in some machine language for speed. We're going to want some local variables to handle the calculations, so let's start with local decimal ABC. Now the local, making everything local is not necessarily required, but you'll have to make sure not to reuse the variables. Well, I mean, you could kind of reuse them, but you know, you just want to avoid conflicts. So making them local kind of helps to prevent that, especially if you import this routine into another program. And next, we need to define the procedure and lay out its parameter format. So proc mod A B. And A and B here are our two parameters. Next, we'll divide parameter B into parameter A. Simple. And then we'll strip off the decimal portion using some assembly code. And this could be done with the int function, but assembly is quicker. And these are the bytes that store the fraction. In other words, we are storing the value 0 into the variable C in memory in the first, second, and third places, which are the decimal places of the number. And now we'll need to grab our remainder. C equals A minus C times B. Due to order of operations, though, we'll need to modify it to the following. Minus A. This will render our results negative, so we'll need to flip the negative sign. assembly is the faster choice. And this is pretty much how you flip the sign. You take the first byte, do an exclusive OR with the value of 128, and store it back. And now that the calculations are done, we'll want to send our results back to the variable waiting at the other end. Send C. And we'll make things global again. And exit the routine. And let's run the program now. So our remainder is 9. To prove that this is accurate, I'll type the following. A equals 29 times 38 plus 9, print A. We're not given the multiplicand of 38. Big word there. Kind of tongue twistery. But I did the math ahead of time. We're expecting the result to be 1,111, and that's what we get. Yay! And I'm going to list. Now, if I remove all of the overhead in this routine and just do everything in assembly code, I'm sure the computations would be somewhat faster. But I'm under the impression that you'll still have the bottlenecks when it comes to the division you see in line 1020 and the multiplication in line 1040. These are just relatively slow calculations compared to the rest, and they're not going anywhere. And I'm not aware of a faster way to generate a remainder than by doing all of this math work here. If anyone watching knows a quicker method, let me know in the comments. One easy way to speed things up is to limit everything to unsigned integers in the range of 0 to 65535. You don't really need a function for it either. For example, equals print x. And again, here you go. The result is 9. And you can use variables here instead of values, but this statement here executes much faster than the mod routine we've just created. The nice thing about using integers is that dividing by 29 and then multiplying by 29 pretty much eliminates the fractional component that we need to eliminate anyhow. Now, the mod function in lines 1000 to 1080 could be modified to work with integers only, and I'll just paste the code here to make it quicker. Smaller and simpler. And we can run it just to test it. And there you go, 9. It's like deja vu. Backtracking a little bit, there is another way to calculate a remainder. It works in theory, but has a drawback. Let me show you. Decimal mol A, B, C, A equals 1, B equals 29, C equals A divided by B, C equals frac C, C equals C times B, and print C. Oh dear, I've typed something wrong. Let's figure this out. Have a extra comma in there, Sonny. Okay, let's clear his junk out of the way. As you can see in this program here, we divide 1111 by 29, remove the whole portion, and multiply the fraction by 29. This should, in theory, produce the remainder. The problem, as you've noticed, is that the results are a tiny bit off. This is because the numbers stored in memory don't have infinite decimal places. So I'm not sure what good this value would be. Alright, that pretty much sums up my lesson here on how to reproduce the mod function and how to create and use your own user-defined function in Vision Basic. So let's talk about the bug that remains when it comes to using the extra program banks in Vision Basic. My last video discussed their use, and I thought I had fixed all of the bugs, but alas, I have not. Let's enter file mode so that I can demonstrate. If you go over to the Details tab and go down to where you can change the bank value, you can select which bank you wish to change the details for. Let's change this number to 7. When I was programming this specific page, this whole page you see here, I was unaware that by changing this value, you're actually changing which bank is supposed to be the current bank. In other words, you're choosing which bank you want to work in and thus view the code for. Now if we go back to the Banks tab, you'll notice that Bank 7 now has a pink off indicator here. This means that Bank 7 is turned off, but is also the current bank. If we exit file mode and type list, well, you'll see some code. Now keep in mind we're in Bank 7 right now, but we're able to list the program that resides in Bank 0. If we enter file mode again, you'll notice that there is a little line here that indicates that there is now some code in bank number 7. What has happened is that the pointers for the code in Bank 0 have been copied over to Bank 7. So both banks now point to the same exact data. Again, the reason this happens is because I was unaware that, I'm going to go back to details. When you change the bank value on this page, you're making it the current bank. But the pointers don't get properly updated upon exit, because I didn't know that the current bank value was being changed on this particular screen. I simply thought that the details for the bank were being altered, not the actual bank chosen as current. As a matter of fact, the manual states that changing the bank number here will not make it the current bank when you exit file mode. So the manual is wrong, sadly. So the workaround for this is to change the bank value you see here back to what it was when this screen first opened up as, before leaving this tab. The damage here has already been done, so we can't reverse it now. Since we started out with Bank 0 when we first opened up this tab, we could edit the details for any of the banks of our choosing, but we'd have to change the bank value back to 0 before exiting, even if we're just changing tabs. So just keep this in mind if you're toying around with the different banks in Vision Basic. Now for further clarification, just so there's no confusion, if I'm opening this page and it says, oh, Bank 7, this is, we're on Bank 7 already, and we edit the details here, and then we go to Bank 9 and we want to, give it a title like Flying Cats. I don't know. You don't want to exit, you don't want to exit this tab at this point. What you want to do is go back here, since it opened up as Bank 7, and you want to change it back to Bank 7. Then you should be able to safely exit this page. And there's our flying cats. Now you could still change which bank is the current bank in the Banks tab that you see here. And you can also use the bank command to do this. Just don't permanently change which bank is current on this specific tab. Again, this bug is fixed for the upcoming version 1.2 of Vision Basic. Catching bugs like this is difficult because I don't really use multiple banks for my programming, so I'm not testing this feature day in and day out. And since I'm spending most of my time working on Vision Basic, I pretty much stick with Bank 0 because I've never broken up the source code. I do plan to improve how banks work to the point where most people might actually prefer to work with multiple banks. Now let's focus on a positive when it comes to these banks. I've got to end on a more positive note here. If we go over to the Banks tab, we're like going back and forth, we can of course give each bank a name. even though things are a little bit screwed up here. So title, screen, menu, main loop, level 1, level 2, level 3, level 4, level, guess which one? Guess. 5, yeah. Draw screen. And we're going to change this one to, oops, back it up. Sounds. Now, this was never documented in the manual, and I'm pretty sure it's never been mentioned anywhere else. But you can actually shuffle the banks around. So if you don't like the order of things here, you can actually rearrange things. All you need to do is pick a bank that you wish to move. Let's move one of the ones that's not crazy. I don't know, let's just say we don't like, we think level 1 is a hard level, and it should be further down the list. Okay. So all you need to do is press plus or minus, and we'll just move it down here. And we can also move it back. You just move it anywhere, really. Whatever one that you're on, it gets moved. And then, you know, so we have code in this bank here, and, you know, it's harder code, and we're just like, we just put it at the end there because we don't want people dying right away when we play our game. And then all we need to do, now that we've moved it around, is that we can type, you know, change the, you know, the titles for each one. And 5. But anyhow, this is basically what I've just done here is move the code around. And now level 1 is now level 5, and now level 2 is level 1, and yeah, you get it. The only thing you need to keep in mind is that since the main program bank, which starts out as 0, ordinarily provides more room for code, its size will remain unchanged as you shift it around. So if you have a large chunk of code in that first bank, and then move it further down the list, it will be saved in the order that you see here, and it may not fit within the confines of the bank it ends up being loaded into when you return to Vision Basic and try to load your program back into memory. And again, for just further clarification, typically bank 0 is usually larger in size, provides more room for code, and if we move it further down the list, it will be saved further down the list. And if this you know, bar here is ginormous, the code will be saved in this order here, starting with this one, and then this, and this, and this, and this. So this large chunk of code will be saved in the middle of the program, and then when you try to load it back up, because it'll be loaded, you know, if you restart Vision Basic again, this bank here will be the biggest one, and then by the time it tries to load this one, it's like, we don't have enough room in this bank, so yeah, error. So just keep that in mind. As for why this feature isn't mentioned in the manual, I added new content to the original manual as new features and commands were added, but simply somehow forgot to mention this feature. Okay, and finally, I just want to give you a tiny sneak peek at one of several new features you'll find in version 1.2, and I mean, this is really tiny. Some people are simply used to typing the following into regular basic. Load, 8. And this loads the disk directory to basic memory when you're using regular basic. In Vision Basic, you simply type, dir, and the directory will be listed to the screen without loading into memory. But now I've made it to where if you type load $8 instead of dir, it will do the same thing. It won't load to memory either. So now you'll simply have the option of typing either thing. I think for some people, loading the directory the old way is kind of hardwired into their brains, so I hope this helps. Alright, we've reached the end of this video. As usual, I thank you all for watching. Please like and share my video, and definitely subscribe for more similar content. And make sure to visit visionbasic.net. And then there's mod.